Hello again. This lesson we're going to continue talking about light. But before we can go any further, we really need to look at how we measure light, the different units, for example, we can use to measure light. Yeah. And when we're talking about the different units, we may be talking about the frequency of the light, the wavelength of the light, the amplitude of the wave, the light wave, and also the power and the energy. So we need to look at all these things together and roughly get an idea of how they're related to each other, because they are actually related to each other. So if we're first going to start off, looking at the relationship between power and energy, because there is a relationship. They aren't exactly the same thing, and I think you need to understand the difference between those two things. So I'm going to try and explain those, but I'm going to explain not through using lights, but some other ways which might be simpler for you to understand. So, what is the difference between power and energy? Okay, let's imagine we have, let's say, a hill. And here's the hill here. Oh, okay, it's the plateau, that's the top of the hill. But on one side of the hill is like this, and the other side of the hill is like that, something like that. Let me just draw a baseline in. Oops, daisy. Okay, so I obviously need to extend this hill a little bit here, and extend this one here a little bit. Okay, so there's our hill, for example. Let's just remove this a little bit. So there's our hill. Now, obviously, this hill is a certain height, but let's have a look at how long the slopes are up the side of the hill, right? And let's say this slope here is twice as long, two times as long as this slope here. Yes, does that make sense? Yeah. So this slope here is twice as long as this slope here. So for example, this slope here might be 200 meters long, and this slope here might be 100 meters long, for example. Now, at the bottom of the hill, we have, let's say, a container, and the container contains water. Okay, so maybe something like this, a big container of water, something like that. Yeah. And so there's water in there, H2O. And let's say this weighs 10 tons. Okay, let's say that weighs 10 tons. Yeah. And we want to take it up the hill. Now, we've got a choice. We can bring it up the hill in a car. So let's say you've got a small car, and you can attach it to the back of the car. Yes, and let's say there are wheels on it. Yes, there are the wheels. Okay, right, and you can attach it to the back of your car, right, and then you could bring it up this long slope here, right? Or else you could attach it to, let's say, a lorry. Something like this. Something much, much bigger. Something much more powerful, right? So there's a nice powerful lorry, right? And you could attach it to the lorry, and you could bring it up this slope, right? Now, first, let's say you get in your car and you attach the car to the water, and you try and bring it up this slope. And your car just isn't strong enough to do it. Your car isn't powerful enough to bring it up the slope, okay? So then you go to this slope, and luckily you manage to bring the water up this slope. Now, this truck, right, let's say it tries to do the same thing. So we have another container of water. So you know your car has brought this container of water up here. Here's the container of water, right? And there it is sitting on top of the hill now, right? Now this lorry is also going to bring the water, another container of water up the hill, exactly the same size. It weighs 10 tons, and it goes up this hill here, right? But it only just manages, you know, the lorry is just powerful enough, right? But it brings us up this hill here. Now, so here we have, this is 10 tons, and this is 10 tons. Right. Okay, so I think you understand everything so far. Let me just clear away some of this mess here. Okay, that's better. So, let's just, so we don't forget, it was the lorry which brought up the water over this side of the hill. That was the lorry. And it was your small little car which brought up the water from this side of the hill. Now obviously this is a longer hill, so let's say it took twice as long to bring the water up this hill. But you know, your car managed to bring the water up this hill because this hill isn't so steep. Yeah, the lorry was very strong, and it managed to bring the water up this hill, but it did it twice as fast as you brought the water up here, right? So this lorry did it 2 times faster, right? Yeah, and yet this here, this length here, the actual length, yeah, is 2 times, yes, the length of this over here. So, let's have a look at this situation. What can we say about this situation? We can see that the amount of water which was brought up to the top of the hill, in both cases, in the case of the lorry and both in the case of the car, was the same. Another way of saying that is that the amount of extra energy, yeah, that this container of water has, yeah, is the same as the amount of extra energy this water has, because you know the water containers, yeah, have been pushed up the hill, so they have energy. How do we know they have energy? Okay, let's attach a pipe, right? A water pipe, and the water pipe comes down here, right? And then the water flows through, for example, a turbine, yes, right? And the turbine drives a generator, yes, and the generator makes electricity, plus, minus, okay, right? So, now, that's only we can only create electricity because we have actually pushed the water up the hill, and now the water is coming down the hill, and we call that hydroelectric energy. Now, if we did the same thing here, exactly the same, and we had our turbine, yes, and then we had a generator, right, and it produced electricity, okay, we would get the same amount of electricity out of both of them, right? So they both contain the water on the left, yeah, contains exactly the same amount of energy as the water on the right. Okay, so these two, you know, the energy here equals the energy over this side as well. Okay, right? The energy from this water container is the same as the energy from this container here. But now let's look at the lorry and the car, right? So they both did the same amount of work, but the lorry did it twice as quickly as the car. Yeah? And it could do it twice as quickly as the car because it could go up this shorter hill. And therefore it got the work done more quickly. So therefore we can say, right, the lorry has 2 times the power of the car. So the lorry has 2 times the power of the car. And we know, in everyday life, that sort of makes sense, doesn't it? Lorries are much stronger than cars, okay, right? So, what is power? Well, we measure power in watts. And we measure energy in joules. Sometimes you might see power expressed as, for example, horsepower. Okay, but okay, these are the basic measurements of power and energy. Right? Another way of writing power is joules per second. And that makes sense, doesn't it? Power is joules per second, right? Power is how quickly we manage to do the same amount of work. Right? So the lorry did it twice as quickly, so therefore the lorry is twice as powerful. Okay, I hope that's clear. I hope that's... if not, you can ask me in class a little bit more tomorrow, okay? Okay, see you next lesson. Bye.